In cloud environments, not all traffic should travel over the public internet, especially when the data is sensitive or internal. Well, Vultr's VPC networks are designed exactly for this purpose, allowing instances to communicate over a private, isolated network, helping you protect your data at the infrastructure level. Hello everyone, I'm Sanskriti Harmok, a developer relations at Vultr, and in today's Tech Talk, we will break down what Vultr VPC Network is, why securing internal traffic matters, explore key use cases, and finally walk through a hands on demo to help you understand how to securely transfer data between Vultr Cloud Compute instances with Vultr VPC networks. So, without any further ado, let's dive right in. A Vultr VPC is a private network that isolates your instances from the public internet. It allows you to connect Vultr Cloud Compute instances using customizable IP ranges while maintaining high speed internal communication. And because the traffic stays within Vultr's infrastructure, it's inherently more secure and optimized as compared to public facing connections. There are several ways you can use Vultr VPC network to strengthen your architecture. You can secure application layering by separating your front end, back end, and databases while keeping communication private. You can enable private database connectivity where your database is not accessible from internet at all. And on top of that, leverage internal service communication between microservices, helping you build multi-tier application architecture securely within your cloud environment. Securing internal traffic isn't just a good practice. In fact, it is essential. It protects sensitive user data as it moves between services, prevents unauthorized access by reducing exposure points, and plays a major role in maintaining compliance with the standards like GDPR and HIPAA. Ultimately, securing these flows helps ensure your business continuity, especially as your cloud footprint grows. So far, we have talked about securing communication between instances, not just protecting it, but also designing it to be private, reliable, and isolated from the public internet. Now, let's see that in action. In this demo, we'll walk through the process of creating a Vultr VPC network, provision Vultr Cloud Compute instances into that private environment, and show how they can communicate securely using private IPs without any data ever touching the public internet. Creating private network with Vultr VPCs is foundational to enforcing zero trust principles, minimizing attack surfaces, and ensuring that sensitive data exchanged between your instances never leaves your cloud perimeter. Let's dive into the process and understand each concept step by step. First, log into Vultr Customer Portal and then navigate to VPC Networks present under Network section on Vultr. Click on Add VPC Network to provision a new private networking environment and select an appropriate location where your instances will be deployed. For example, we will go ahead with Atlanta here. You can even choose if you want Vultr to automatically assign an IP address range for your VPC network or configure it manually. For this demo, we will go ahead with Auto Assign option. Vultr by default provides a typical CIDR notation which is similar to 10.6.96.0 with 20 network bits, which allow up to 4096 internal IP addresses, which is suitable for small or medium scale deployments. You can even set up static custom routes for your VPC network, and this will be automatically applied to all the instances to which this VPC network is attached. For this demo, we will go ahead with no routes option. And finally, we will have to provide a relevant name for our Vultr VPC network. Once everything is configured, let's click Add Network to create a secure and isolated private networking environment for our instances. When I say secure, I mean that the internal traffic is protected from external exposure and stays within Vultr's private infrastructure. And by isolated, I mean the network is cut off from the public internet. Now that our Vultr VPC network is activated, we can see that a subnet 10.6.96.0 with 20 network bits is assigned to it. Let's understand this further. There are 20 bits as network bits, so the remaining 12 bits will be host bits, which further implies that there are 2 to the power 12, which is equivalent to 4096 addresses available to us. But out of these, only 4092 addresses are usable because we will be eliminating the reserved ones. For example, 10.6.96.0 is a network IP address. 10.6.96.1 is a gateway address. 10.6.96.2 is in fact an IP address reserved for future use cases, for example DHCP or DNS configuration. And the last address from this IP address range is 10.6.111.255, which is in fact a broadcast IP address. If you would like to understand more, you can use the Vultr IPv4 subnet calculator by just providing the CIDR notation for your network, and clicking on calculate subnet will give you the entire network breakout. You can further easily calculate the subnet mask for your network by applying ones to the 20 network bits we have and zeros to the 12 host bits. Now that we have our Vultr VPC network fully configured, we can head over to the compute section on Vultr and provision two Vultr Cloud Compute instances and attach it to the private network we just created. Click on Deploy Server to do the same. Now select your preferred instance type. We will go with shared CPU. Please select the location same as your Vultr VPC network. So for us, it will be Atlanta. And further, select the instance size based on your requirements. We will go ahead with 1 GB of memory and 25 GB of storage. Further, configure your instance by applying a base operating system. For us, it will be Ubuntu 24.10. Select an SSH key to securely access your instance later and apply a firewall group if needed. Provide a relevant host name to your instance. And because we have our Vultr VPC network already configured, we can select it from this window itself. So click on VPC network and choose the target Vultr VPC network that we just created. We will also configure a non-root user for this instance for security purposes. And that's all that we need. Go ahead and click on deploy. And this action will launch a Vultr Cloud Compute instance, both with a private IP address, which will be used for internal communication with other instances deployed within the same region as demo server 1, and a public IP address, which will be used for SSH access and internet connection. If you couldn't attach Vultr VPC network while provisioning your Vultr Cloud Compute instance, then you can do that later as well. You just have to open the management page of your provisioned instance and navigate to the settings tab, and further open the IPv4 section. Here, scroll down to the VPC network section, and from the drop down select the available VPC network for your region and attach this VPC to the instance. Now allow me to provision a similar Vultr Cloud Compute instance in the same fashion by ensuring that I deploy it in the same region and attach it to the same VPC network as demo server 1. Now both of our Vultr Cloud Compute instances are up and running. Let's transit to the SSH environment to perform further operations. I'm currently on my workstation and I have two terminal tabs open, each SSH into one of the Vultr Cloud Compute instances I just deployed. The left terminal is connected to demo server 1 and the right one is connected to demo server 2. Let's go ahead and execute a command called IPA in order to figure out the private IP address assigned to these instances. In the output, as you can see, there are three interfaces. The first one being a loopback interface, which is used for local communication. Second one being public-facing NIC used for external access. And third one is a special type of interface, as it is an internal NIC connected to our created Vultr VPC network using the private IP address from our subnet. The private IP address assigned to demo server 1 is 10.6.96.3, and the private IP address assigned to demo server 2 is 10.6.96.4. ENP8S0 interface is exclusively used for handling internal traffic within VPC network. Having separate network interfaces helps in isolated routing between internal and public traffic. Now let's install NetTools package in order to verify the routing table for both the instances. Once this is done, execute routeN command to verify the routing table. You will be able to notice a line similar to this, which indicates that any traffic that is destined to this particular subnet, that is 10.6.96.0, will go through ENP8S0 network interface, which in turn is connected to our provisioned Vultr VPC network. A similar line you can notice in the output for demo server 2 as well. Now let's test instance to instance secure communication. For this we will be using rsync, which is a command line utility used to transfer files between instances or devices. We will go ahead and check if our system already has rsync. Yes, we do. If you do not, then install rsync using apt package manager. Now we will create a test file of 500 MB on demo server 1 using dd. The input file that we are passing is a special type of file which contains a stream of 0 bytes. The output file is simply the name of the file that will be generated as a result. Block size is assigned as 1 MB and the count provided is 500, meaning that there will be 500 blocks each of 1 MB in size, making it a total of 500 MB. Let's hit enter. As a result, our test file will be created, but let's cross verify it in the home directory. Now that the file creation operation was successful, let's finally try to transfer this particular file from demo server 1 to demo server 2 using the private IP address of demo server 2. There are several flags that we are using in this particular command. For example, A for archive mode, B for verbose, C for compressing the file while transferring it from demo server 1 to demo server 2, and P for showing us the progress while the process takes place. We are providing the username of demo server 2, which is Linux user, and the private IP address, which is 10.6.96.4. We will be transferring this file to the home directory of demo server 2. Let's go ahead and hit enter. Because we are mentioning the private IP address of demo server 2 for the first time in this particular SSH session, therefore SSH is prompting us to verify its authenticity. Go ahead and type yes, and further provide the demo server 2 password, which you can easily fetch from the overview page of demo server 2 on Vultr customer portal. It shows that the file has been transferred. Let's switch to the SSH session of demo server 2 in order to see if we have successfully received the file. This result verifies that the 500 MB test file has been successfully received and is stored in the home directory of demo server 2. In the similar fashion, you can even transfer the bulk files or even sensitive information from one Vultr Cloud Compute instance to another by configuring the Vultr VPC network. To wrap things up, we have seen how Vultr VPC network help you secure internal communication between your instances, protect sensitive data, and build a scalable layered architecture without exposing anything to the public internet. If you would like to get started, you can create a Vultr VPC network directly from your account and begin connecting instances privately today. In order to make it even easier, you can use a custom promo link attached in the description below to claim $250 in free credits on a new account. Thank you so much for tuning into this tech talk. I hope this gives you a solid foundation to start building safer and smarter cloud environments.